There we go. Cool. Hi, everyone. So thanks for your patience there. Many thanks for joining this Q&A. So even though it's August, even though many people are no doubt on their vacations and holidays, we at MESHWORK are still keen to provide a continuing programme of events, sessions and educational pieces. So it's good to see a healthy take-up on this Q&A. The aim of this session, with your involvement and the help of Andy and Doug, is to look to cover the causes of overheating in buildings and how to mitigate against it. Now, it is a Q&A. It would be great to have your involvement. We're here to learn, to share. So no one person is going to know any more than anyone else necessarily. So yeah, please get involved. You know, we want you guys to get the most out of it as possible. Sorry, I'm just busy admitting. So yeah, just firstly though, just to cover off some admin, please keep your microphones on mute. That would be most helpful. Thank you. And we do have a chat function, so ask any questions through the chat box. As you may have heard right at the start, this webinar is being recorded. It will appear within Mesh Energy's YouTube channel and within MESHWORK itself. If you do ask any questions through the chat, then it may be that I will ask them on your behalf, or at the right point, I might ask you to come off mute and ask it for yourself. But yeah, please get involved. So yeah, as I said, this being recorded. I can see from the RSVPs that actually you've all been on MESHWORK for a while. So in terms of sort of describing MESHWORK and giving an update on MESHWORK, I'll quickly skip this slide. However, what I would like to say is that if you do see value in being a member of MESHWORK and you'd like to help quicken the pace towards a time when buildings are inherently sustainable in design and operational use, then please spread the word. There is a referral code within your profile settings. So yeah, share away. It'd be great to have more people come along and join these types of conversations and quicken the pace, as I said. And if you want to loop me into any introductions, I'm here to help. So yeah, please do so. In terms of this Q&A, I've allocated 30 minutes, so I won't spend too much time just talking and doing the intro. Depending on how it's going, I imagine there'll be some quite good chat. I don't necessarily want to cut it short, so we might overrun slightly, but you know, I've allocated 30 minutes, as you'll see from the event. Mesh was set up by Doug, who's at the top of the list there that you'll see. So MESHWORK is an independent provider of net zero carbon building performance and engineering services to architects, developers and homeowners. But I'll let him expand on that, because in a second I'll just ask Andy and Doug to introduce themselves. But it would be great, before I do that, if you guys could introduce yourselves within the chat. Just say who you are, what you do, why you're here to do, why you're here today, and what you'd like to learn, if anything at all. And so I'm just letting someone else in. There is another question here that I will just skip to, just to give this some food for thought. So once you've introduced yourselves on the chat, have a think as to whether you've had any project, because we're keen to learn from you as well. So have you had any projects that overheat? Did you fix it? If so, how? Make sure it's AM. And then someone, let me just put you on mute.
Before he's come in, is that all right? Yeah, all right, brilliant. So it's AM. Can I take your telephone number?
There we go. Before we got his telephone number. Right, okie doke. Yeah, sorry. So as I was saying, please just give these questions a bit of a thought, and if there's anything you'd like to share in the chat, then do so. So if I just hand you over to Andy, just a quick 15 seconds, who you are, why you're an expert on in this. Well, no, sorry. Andy from Expert Energy. Yeah, just a quick 15.
It's a bit presumptuous name, isn't it? Expert
Indeed,
Energy.
indeed, yeah.
I feel like I'm building up a reputation before I've actually earned it. But no, I trained as a physicist originally, so I hope I've got a decent understanding of building physics at a sort of general kind of level. I'm an independent consultant now, have been since 2010, and set up my own consultancy then. My focus is really on existing buildings rather than new builds, but I certainly speak to a lot of homeowners who've had new builds or moved into new builds and have a degree of understanding as to sort of the issues that they're trying to deal with. So hopefully I can contribute something.
Cool. Thank you, Andy. And Doug?
Yeah, cheers. Good afternoon, everybody. Again, I'm going to make this super duper short because I've introduced myself probably 500 times doing webinars over the last 2 years. But as Simon said, I set up Mesh Energy. I've been in the sustainable built environment for 15 plus years now. We're doing new buildings, existing buildings of all kinds of scales, and building a team to just try and better understand things like overheating, embodied carbon, just building use to renewable technologies, and trying to smash that way forward to make sure we're just designing buildings more intelligently. And as this MESHWORK platform attests, the quicker we can share this information, the quicker we're going to be able to combat a lot of the big issues that we're up against today, and they're only going to really get worse. So, Simon, do you just want me to kind of rattle into this then and get going?
Absolutely. Yeah,
So the gist of this is just to kind of keep it nice and easy breezy. We haven't got a big presentation here. What I thought it was just worth doing was just doing a quick kind of 30-60 seconds on the kind of high level Part O regs, which came out in June. And then Andy and I will talk around a few questions. But as Simon said at the start, I think it's really important that you guys have a think about how overheating has affected you, your projects, other projects you've been aware of, how cheap or as expensive has it been to fix these things. It's a really, really complex problem. But what we're after here is experience and learning, and we'll share what we can do within the remit of probably what's 25 minutes left. And we'll try and get you guys to do that as well. I don't want you guys listening to me drone on for half an hour. We want to hear from you. So don't be shy. Feel free to share. So just a quick one on Part O. This came out in June of this year. Many would argue it's been a long time coming and really broke out some very, very basic calculations within the standard assessment procedure methodology, and now stands alone in its own part of building regulations. And really it's the right level of due diligence that now needs to be done for buildings, proving that you've put the effort into analysis. So at the moment, Part O is for new residential buildings only, and that's worth understanding. It's not for all buildings, it's just for new residential buildings being built. And specifically, we're talking about homes, flats, student accommodation, HMOs, which are houses for multiple occupancy, if you're not familiar with that acronym, and care homes. So all kinds of different scales and uses, but fundamentally residential, and we're talking about new buildings. And there are two ways of showing compliance for buildings. One is using what we call a simplified method, which is very much almost kind of spreadsheet based, although they've got software around it. It's based on window areas, orientations, proving cross ventilation quantities and stuff. But for most buildings, it's difficult to get a pass under that simplified method just because of the nuances of buildings. So one of the other ways of doing that, which is the more involved method, is the dynamic thermal modeling method, and something called TM59, which is a CIBSE standard, and we use day in, day out. You can essentially build a building physics model, not for a huge amount of money, but really work the problem in the building and prove compliance in a much more kind of detailed and sophisticated way. So Part O, generally speaking, will apply to all new projects unless you have an initial notice which has been submitted to building controls by the 15th of June and you start work before the 15th of June next year. You won't have to deal with Part O, but for all new projects going forward, you will have to come under these regulations. So where we wanted to kind of start with was the first question we want to start with. I think we've kind of, just in the explanation that I've given here, we've kind of covered off, you know, what do the new Part O overheating regs mean for projects. Really, it's more due diligence. Yes, it's another load of calculations, and it's, you know, you're going to need to prove that there's actually been some calculation and methodology gone into those buildings. But as far as the kind of the main culprits for overheating, you may have a fair idea of what these are. But it'd probably be worth just handing over to Andy just to list his kind of top 3 or 4 ideas for what causes overheating in, let's say, existing buildings, given Andy, that's your kind of specialism. So what, off the top of your head, what are the really big kind of evil culprits of overheating in existing buildings?
Yeah, I mean, if I was to break it down to 3 areas, I would say, I mean, solar gain is huge. And I think people who suffer the most are those who've got, there seems to have been a fad for open plan conservatory designs, which merge into living rooms, and they are practically unlivable when the temperature rises about mid 20 degrees. And I've heard reported temperatures, you know, internal temperature of about 40 degrees C. And we have sort of similar issues with, you know, skylights, large areas of glazing, especially facing east and west, because that's when the sun's lower in the sky. South facing, not so much, because the sun in the summer is fairly high in the sky. So, you know, large areas of glazing is probably number 1, I would say. Number 2, I think probably a lack of the ability to get rid of that heat, and, you know, having the ability to, you know, cross ventilate is clearly key to cooling the building structure down. Most of the heat in the building, whether we're talking about space heating or overheating, it's stored in the structure. It's not in the air around us. So far more heat is in the structure, and it can take hours or days to actually get rid of that. So having some sort of cooling arrangement is absolutely critical to keeping a comfortable environment, in my experience. But I also wanted to say about internal gains as well, because this is not really discussed, and perhaps it's not really considered as an issue. But, you know, I can go into big houses, and, you know, from electrical consumption, there's, you know, a kilowatt of heat gain or more in many cases. But I often find with poorly controlled hot water systems, I mean, there's a huge amount of heat loss from these things, and we're talking about secondary pumped circulation systems. I've seen the energy use in these be equivalent to the space heating demand. I mean, it's absolutely staggering when I actually look at what's being used in the summertime, and all of that effectively gets lost into the house, apart from a little bit that goes down the drain. You know, we're talking in many cases 25,000 kilowatt hours of heat load all year round. So you have to pay real attention to not just the electrical, but also particularly the hot water, and clearly, obviously, you don't want your space heating running longer than it needs to as well. So those are my kind of 3 sort of main culprits, if you like.
Yeah, I mean, I concur. I think a big one that a lot of people just simply don't realize, and when you solve the problem around ventilation, it's incredible how much of a difference that makes. So no doubt we've all been in rooms and buildings, often usually at the top of those buildings, when all the windows are shut and it's blazing outside and it's like an oven. And as soon as you open a window on one aspect of the building, and then you open another window on another aspect of the building, or a skylight, within a matter of seconds, if not, you know, a few minutes, all of a sudden the temperature drops away. And I was going to add to that. I mean, there are, in a very technological world that we live in, sometimes it's the very simplest solutions that can solve some of these building overheating issues. And one of them is opening skylights. The amount of new buildings that we see that have lovely vaulted ceilings, and maybe a mezzanine in them, or maybe just an upstairs landing that has no way, no lovely big stairwell maybe, and there's just no way in the summer, or even the kind of the late spring or autumn time, for that heat to get out. Just a simple skylight or something to purge that energy at a high level has really stung a lot of people, and we've seen people spend a lot of money. You know, we're talking life savings on building their lovely, you know, home. You know, they're in their 60s and they've finally, you know, got that money to put into a great big, lovely new home. And just because they haven't put in roof lights has meant that after the event, they've had to put on solar films onto windows and messed around, and it's just an uncomfortable place to be. And these are places that they, you know, are the kind of the hubs of the home. So I think ventilation is a big cause of overheating, but actually can be quite a simple way of relieving overheating. And solar again, once the energy is in the building, once the sunlight has got into the building, then, you know, somehow you've got to get that energy out. And so, you know, shutters and things like that. There's a good reason why in a lot of European countries they have shutters on their windows and actually physically stop the light getting in, or they have overhangs and things like that. And that's because it's hundreds of years worth of tried and tested overheating that they've been suffering from.
And how expensive are these solar films then, Doug?
That's a good question. Off the top of my head, I'd be lying if I said I exactly knew, but it's still going to be, depending on the window area that you're trying to cover. You know, it could be hundreds or it could be thousands of pounds. Right. I mean, in this particular case that I was talking about, they had a massive, great big, you know, tens of square meters of glazing in their kitchen because it went out into a lovely garden, and they were having to cover, you know, a big area, and they were testing and they had to try different ones and all kinds of things. But I mean, again, kind of solar films, they're like a you know, a band-aid really for something that should have been they shouldn't have had to do it. They simply shouldn't have had to do it just because they didn't do the kind of the proper analysis. So existing buildings are a tricky one. Usually a lot of existing buildings have thermal mass, but I just want to touch on a point here, which I think was the next question that I've got, which is about the paradox between lovely new well-insulated buildings and overheating. And I think this is causing you know, a kind of a big problem for a lot of designers at the moment, because bizarrely, it's now not so difficult to keep buildings warm because of the way that building regs have gone for new buildings. The issue is now in the summertime and making sure we can get rid of that energy out of it. And with a lot of us increasingly being made aware of the passive house methodology and passive house principles and things like that, you know, insulate, we are becoming increasingly aware of highly energy efficient buildings which are almost inhabitable during the summer months, because they're doing kind of too good a job in one respect, but holistically the buildings haven't been designed to make sure they're habitable all year round. And I think that is, as we do more analysis on buildings, that should become more and more clear. And again, it might be worth just kind of asking anybody else who's on here at the moment whether either they've been caught out in buildings that they've designed, or they've been in super insulated buildings. And internal heat gains from plant rooms is another good one as well in these very well insulated buildings. You know, it can lead to overly warm buildings in kind of spring, summer and autumn months.
I don't know whether George wants to come off mute, because you've asked a couple of questions on the chat.
It was purely just expanding on the comment, Stud, that you've made. All very good, but like with ventilation, typically we've got a lot of scenarios on the new build front where, okay, ventilation, cross ventilation, open the windows, and then we have, especially in London, the internal air quality issues, and then the conflict with a noise survey, and the fact that, you know, and then it's like purge ventilation. It's like at the moment implementing Part O is causing chaos, because what takes precedent? You know, there's not a fix in some of these situations. It's where do we go?
I mean, it is a really tricky one, and this, you know, some apparent solutions are obviously causing new problems. They always do. Solve one problem and another one crops up somewhere else. And you know, in cities where you've got that kind of heat island effect anyway, and as you say, you've got increased noise pollution, you've got increased noise and particulates in the air, and you know, air quality is not there. It is a tricky one. I mean, we have you know, on previous projects, whilst you know, you could argue that rather than having trickle vents, you could go for mechanical ventilation, heat recovery. In the summer, you're still looking for that summer bypass, because the last thing you want to do is bring hot air into the building that's already overheating. And no doubt somebody will come up with a solution. But I don't. You're not the first, George, that we've heard from that question's being asked. I know Richard. I think Richard put something on MESHWORK recently about that same kind of issue. Richard Bowman on our side.
There doesn't seem to be a definitive answer, and again, I kind of cheekily said it when I joined the call about SAP 10. Yeah, and it is so many grey areas and unanswered questions at the moment, and no one knows the answer, because purely, you know, we're learning as we go along. I just didn't know if you guys had where to turn or who to listen to in these circumstances.
Well, I think it's you know, I think this is where a kind of group think comes into it. I think, you know, we're entering a realm now where, you know, you obviously can't rely on the building controls officers to come up with solutions. It's us as a kind of a group who care about it. They're coming up against it, and you can guarantee that, George, you know, hundreds of people now have come across projects that are facing the same kind of issues. So it's I guess trying to put our knowledge together. We're obviously going to be limited in some respect as to what kind of technology and what products are out there. But for example, you know, and this is just off the top of my head, you could argue, you know, if you've got a roof light at a high level in a building, that allows you to purge air out of a building. But I would argue that the noise impact on the household, even if you're in a noisier area, it's probably going to be minimal, just because of the, you know, geometry of the space and where the opening is. Air quality is something different.
It's difficult, because then that again, sorry guys, but that's when the environmental health officers then pipe up and say, well, you're not meeting the internal noise measurements required. And again, London is worse because of London Plan. It's unfortunately the different departments. You know, you've got environmental health, we've got us we've got building control on a case. I think it still needs proper talking about, and these grey areas addressed.
Yeah, and you're going to be down to you know, filters or baffles or something in order to do that. And I think the only way in which you can make progress, I still think a lot of this is far too subjective. You know, somebody will say no simply because the numbers haven't been crunched on it. There could be a kind of a big generalization there, but I think that's where design teams need to get a bit more serious about, you know, making sure that the analytical team is working together and the numbers are reliable. Because often, I mean, we find often that, you know, if you've got the numbers, first of all, you know with confidence what those numbers are, but often, you know, building controls and other people involved, you know, will back down, because at least you've done the analysis and showed that you've tried to mitigate it. And that's I think that's what we need to kind of continue to do, just try and make sure that we can convince the client that's what's needed, just more analysis and kind of, I guess, better relationships between the various people working on it. And so you can kind of beat the building controls officers up a bit more with the data that you've got. But again, when success is had, being able to share that would be really, really useful.
With you mentioned it previously, how Andy did, when it comes to sort of buildings on the continent and how they've had this problem for many a year. And then Donald's just made the point about how much does lightweight construction. Yeah, so not Donald, but Richard as well has looked at sort of looking at more traditional methods, you know, round orientation, etc. And
well, Andy, do you want to pitch in with that Andy, on kind of construction mass versus risk of overheating?
Yeah, it's a double-edged sword, I think. You know, I mean, I see clients in all manner of buildings and ages and designs, and invariably in the hot weather, it's those with, you know, heavy construction from, you know, centuries past, you know, with uninsulated stone floors. I think that's probably a key thing. You've got an uninsulated stone floor, you've got a big heat sink underneath you. And I mean, thermal mass, it can work with you and it can work against you. You know, for the first few days of a heat wave, it will soak up that excess heat. But then it's like a storage heater, and it can take days to actually get rid of that through proper ventilation. So, you know, the flip side is if you have sort of internally insulated structure, the building heats up more quickly, but it also cools down more quickly when you start to open the windows. So, you know, it really depends on sort of the climate around you in terms of sort of, you know, how quickly is it going to cool down. The weather, you know, we seem to be getting into longer patterns of heat these days, whereas 20, 30 years ago, it was, you know, a couple of days of heat and then it was gone. And, you know, lighter weight buildings, you know, can shed that heat very quickly, whereas, you know, the thermal mass, it plays into that sort of longer game, if you like.
Yeah, I mean, you know, I always, the way that I think about it is, you know, the lighter weight a building is, the more responsive more responsive it is either to cold weather or hot weather or anything in between. Whereas, you know, heavier buildings are slow and sluggish, that you can, you know, roast them on one side and it'll take them ages to do anything on the other side of the wall. And it's yeah, the emitter thing is difficult, you know, like you warm up a stone or a, you know, pizza oven or whatever analogy you want to give, and then the fire goes out, stays warm for ages and ages and ages. The good news is, as human beings, we you know, we can respond, although we don't want to throw kind of mechanical systems at this. Again, if you've got decent ventilation and it's cooler outside, there's a way of cooling yourself off, even though the fabric of the building may be warmer. Just aware of the time, it would be interesting just to kind of open it up actually to other people on the call, just to talk about your experiences with overheating and whether you guys have solved those problems, whether they got really expensive, you know, solutions and issues. Is anybody kind of brave enough to share a story either on one of their projects or another project that they became or are aware of, just to talk about it, if there are any learnings that the rest of the group might be able to benefit from? Is anybody in a position to do that? Feel free to unmute yourself if you want to.
Chris just raised his hand. Would you like to unmute yourself?
Yeah, sure. Chris Ridge of TICA. We're the Thermal Insulation Contractors Association. So you can probably guess from the association I work for where I'm heading with this. But essentially, it was mentioned earlier in approved document O, and how it's catering for some of the larger builds in the residential market, such as student accommodation and assisted living and quarters and things like that. Really, just to add in a bit of input in terms of the building services as well, and my experience from poorly insulated pipe work on the heating systems and on the hot water systems, particularly where they're connected into heat networks, is very problematic. And one of the things we're trying to do as an association is to obviously promote better practice in that respect. But I guess just back to the panel, really, have you seen that yourselves in any of the larger buildings you're looking at, that overheating of pipe work has been a significant contributor? And how do you see the proliferation of heat networks for all the work that the government is doing to try and, if you like, get to an energy resilience? How do you see the proliferation of heat networks affecting that potential for overheating? Thank you.
Yeah, I think George just came back and said he was, yeah, he completely agreed with that centralized, you know, pipe, kind of a heat emitter issue. I know a case study I've used for the last few years was a project that we became aware of down on the south coast. Huge issue there. The central atrium where all the stairs went up over 5-6 stories, all the main flow and return pipe work went up that, and it was basically just a greenhouse. Nobody had thought about the temperatures, and it just turned into a massive chimney, and they were recording temperatures in excess of, I think, high 40s or maybe even 50 degrees in the stairwell. And all these flats that went off this stairwell were then suffering as well because they were single aspect flats. But one of the things that was learned from that project was the pipe work, that centralized distribution pipe work, just wasn't insulated really, which was, I guess, fine in the winter, but in the summer, it just turned into an oven, and that cost them over £500,000 to sort out that issue, because they had to ventilate the top and the bottom of the building to create, you know, almost like a passive stack. And anybody else got anything that they fancy sharing on their projects? Success or failure or both?
Yeah, forgive me. I'm not sure the first name, but Jay Horner was making a point about sort of running a cost benefit analysis, and that in order to install the exterior leaf technology, but it was just decided that it was, you know, the benefits were just such that it wasn't viable. And it just makes the point about, you know, the solution air conditioning, which isn't really where we want to go, obviously. So it's yeah, it'd be good to know if there are any other solutions out there, or if people have experienced other if there are any other solutions out there that people have tried. Internal courtyards, Richard mentioned, for those lucky enough to have them.
What was that for? Keeping, will creating internal courtyards help? In what respect, Richard? For keeping things cool?
Yes, Doug. Yeah, I mean, we see it certainly across the continent, and thinking about even things like affordable living schemes where we're building larger blocks of flats, creating those internal courtyards, which can not only encourage biodiversity, but also be a place where you can, you know, you've got natural sunshade and
Yes,
less solar gain.
No, I mean, we've I mean, the few projects that we've done, I can remember vividly a domestic project that was lucky enough to have an internal courtyard, and you know, that was a lovely space even in summer. I mean, you know, with all the 3D modeling capability that we've got now, the ability to see what stuff's going to be in shade, what stuff's going to be in sunlight throughout the year, you know, almost minute by minute now is so helpful. I mean, we keep kind of banging on about this, but we're now kind of getting to the level where so much stuff is interlinked here. We really need to get on top of this as early as possible in projects. And of course, we need to understand the benefits ourselves, but we need to talk to the clients about, you know, what the potential risks are here. You know, sometimes we get a bit taken away by creating beautiful looking buildings, or I guess functional in some respects, the buildings. I think that the risks here are the stakes are raising quite dramatically. And I think until we can properly model these buildings and find out what the numbers are telling us, we're going to struggle to keep some of these solutions kind of cost effective. I can promise you that a lot of these solutions to the overheating that we're talking about here are often simple design issues that just haven't been caught. In almost every single case, it's not something super duper complex. It's just something that's simply been overlooked as part of the design process. Again, you know, kind of time's kind of run out, but probably be interesting to maybe do another one of these things on the actual kind of overheating design process. Again, what's being done at the moment versus how you might tackle a project from first principles, considering overheating risk or ventilation risk, or the combination of those, including kind of thermal mass in that as well. Because again, you know, the aim of the game here is to de-risk the projects and it not cost an absolute fortune to do so, in order that clients actually go ahead and pay for it and do it, and we can kind of sell that in earlier on into the projects.
There's been some good chat here, actually, and we will upload the chat to MESHWORK as well, so you can see it. So I mean, Sarah's just asked a question of Richard, and perhaps she'd like to follow up with Richard separately using the chat facility anyway. So there seems to be some things that have been suggested, and lots of conversations could be triggered from this. Yeah,
Yeah, Derek's asking about passive house principles without MVHR and manual opening windows and doors and extracts and things like that. I say this is a massive conversation, and it's not going to go away. So there's lots of kind of subtopics that we can talk about, and that's why you know, if any of you guys have got case studies or a bit like George was saying, if you find a manufacturer's product that seems to tackle, I don't know, filtering air, but making sure that you're able to get a decent through flow for a certain regulation, you know, do feel free to share that, because in every single building that's being done, you know, at whatever scale here, although we're talking about residential, you know, just because the regs cover that, it's going to affect every single building, and you know, the more quickly we can kind of share some of the findings here, the more quickly that we'll make ground. And we've got a commitment as Mesh Energy to share, you know, again, what we know. Be fascinating for you guys to be able to share what tidbits you've got as you know, as you go through your projects as well. But there's a whole series of talks like this that we could do around overheating, and just make it a bit more thought provoking for you guys to share as well.
Yeah, that's cool, and that gives us an idea in terms of how we can follow up here. And then when I upload it, you know, because Richard Bauman, you mentioned him earlier on, he just earlier this week posted something around using or the use of grey water within gardens, and there's a nice piece of kit that he shared. Or was it? Yeah. Or no, it was Richard.
Yeah, it was Richard. Yeah.
Yeah. So it's through this. If there's anything that's going to be relevant to this, it's like the more people share, as you said, in terms of kit solutions, or putting parasols up in front of windows, as one blogger showed yesterday. It's yeah, lots of ways that we can carry on this conversation. It is 22. We did allocate half an hour, thinking for Q&A we probably wouldn't need an hour, but obviously there is plenty of chat. But I think it's probably best that we do draw this to a close. But from this, there's definitely an appetite, a reason, and value in having a follow-up. But we will do that in very near future.
Yeah, and just to back up what Simon's saying there, you know, if you guys want to talk about anything particular, just fire a note over to Simon on the, you know, on the chat function on MESHWORK, and we'll, you know, that we're trying to put together discussions and content that you guys want to hear about. So if you don't tell us, then we're going to be thinking of something else potentially. But yeah, do let us know if there's anything that you can think of subject wise. Would be greatly received.
Cool. No, thank you very much for attending, guys. Yeah, enjoy the rest of your week, and yeah, we'll speak to you soon.
Thank you. Cheers, everyone. Take care. Bye bye.